Today we're going to build a Pokedex from the Pokemon data that we scraped in the last episode. So here I have a diagram of what we're going to be building. There you go. So on the left side of the diagram, you can see what we created in the last video, which was the Pokemon scraper, which scrapes a Pokemon website and then puts the data in a MongoDB database. If you look at the database itself, over here you can see the MongoDB database that we had, and we have all, so you can see all 1045 Pokemon over here with all their data, like the name and avatar, the entry, and all the different stats. So today we're gonna, based on that data, we're gonna create a Pokedex where if you tell the name of the Pokemon, the program is gonna recognize which Pokemon you just said and give you all the data related to them. The way we're going to do this is we're gonna pretty much have a script which is gonna be written in Python. We're gonna use AWS Polly. It's a service that Amazon provides. What the service does is pretty much it's text to speech. So we're going to form the text that the Pokedex is going to tell you, and then we're going to use Amazon Polly to say it out loud. So to give you a quick overview of how the whole thing is going to work end to end, we're going to start from the bottom of the diagram here. So whenever you say a Pokemon's name, let's say you say Pikachu, the script is going to recognize what you just said, and then it's going to look up the MongoDB database to find the Pokemons that are there in the database closest to what you just said. So let's say if you say Pikachu, we're gonna get the data for like Pikachu, Mega Pikachu, maybe Pichu, so all the Pokemons that sound similar. The way we're going to do this is by something called a Lucene index. So MongoDB has it built in where you can just configure your database to use this index. What it does is it gives you the ability to do search, like any kind of autocomplete search, where you can give it a string. They do something called a fuzzy match, I think. What that means is pretty much when you give them the name, they're going to find you the closest words to that query and give them back to you. So it doesn't have to be an exact match. That's because when you say the name of a Pokemon, it's very much possible that the program won't get the spelling correct. So if you were to do an exact match with the Pokemon name, most likely you won't get the result because the spelling might be different. So you want to do a fuzzy search where as long as the names are similar, you're going to get the result from MongoDB. So yeah, so you're going to say the name of the Pokemon out loud. The script is going to look at the MongoDB database, use that search index to get you the closest match. From there, from the closest match, we're gonna use an inbuilt Python function to get amongst the ones returned which matches the most closely. And then we're gonna use the database entry for that Pokemon, form a string that the Pokedex would say out loud to you. We're gonna use AWS Polly to convert that text to speech. Once the conversion is done, it's gonna give you an MP3 file which you can download locally. And once we download the file locally, we're gonna use PyAudio to say it out loud. So I have the whole system built. I built it like last week. So today I'm gonna go through the whole code, copy paste the code line by line, explain all along how things are working, so that you can like follow me very closely. Alright, so without waiting much longer, I think we can get started. Alright, so over here we have the Pokedex. So the first thing we're going to do is import all the packages and functions that we want. So I'm just going to copy paste all the imports. There you go. So I'll just run through all of them. So we have the speech recognition. So what this does is pretty much lets you use the microphone in your computer so that you can actually say the name of the Pokemon out loud and the computer can recognize it. We have the Bodo 3 library, which is the AWS client we use. You need to use this whether you're using AWS S3, Redshift, or any other services. In our case, we're going to use it for AWS Polly, which we're using to do the text-to-speech translation. And then we're going to use PlaySound, which is a package we're using to play our MP3 files. So you can pass your MP3 file to this function, and what it does, it just like plays it out to you through your console. We have the Mongo client over here in line 8, which is the MongoDB client that is going to let you talk to the database, make different queries, and even do all the search queries that I talked about previously. We have the MongoDB client URI, which is pretty much the URL that you use to connect to the MongoDB cluster where our data lives. So that would be, let's just see, that would be the data over here. Or through the client, we can talk to all the data that lives in this cluster. We have the AWS access key and the secret key. These are pretty much the AWS keys that you need to interact with any AWS service. Once again, in our case, that is going to be AWS Polly. And lastly, we're going to use sequence matcher from difflib. It's a Python built-in package. What it's going to do is it takes in two strings and it tells you how similar two strings are. So let's say if you have two strings that are very, very close to each other, the number it returns is going to be very high. But if you have two strings that are very far from each other, like they have different spellings, they sound differently, then you would get a very low number. So you're going to see how we use the function and why we actually need it. So that's pretty much all the packages that we will be needing. And the first function that we are going to need is the one over here. So it's called similar, and it takes in two inputs, A and B. And this is the function that calls sequence matcher, and you give it none as the first parameter, and then you give A and B, which are the two of the inputs, and it spits out the ratio. So what this does is it's gonna, let's say you have two, right? You have like the first input, which is cat, and the second input, which is also cat. They're an exact match, so you're gonna get a ratio of 1, which means it's like 100% match to each other. However, what you can do is, let's say you have like 4 different variations of cat, and you want to see which of these variations is the closest to the spelling CAT cat. And if you pass all 4 through this function, you're going to get the most likely as the highest ratio. So where we're going to use it is when, as a user, you tell your Pokedex to tell you about Pikachu, and we look up at the database, and let's say it returns to you like 4 versions of Pikachu, like Pikachu. It gives you Mega Pikachu, and it also gives you Raichu because it sounds similar to Pikachu. Then you can use this function to find the closest one to the actual Pikachu, and you're gonna see how it works when we get to it. So now that we have this function, we're gonna just do some boilerplate code, which is the first thing we're gonna do is set up our database connections. So we are pretty much creating the MongoDB client by passing it the URI. What the client returns to you is the connection, and through that connection we are just going to choose our DB, which is YouTube, and you can take a look at it over here. So you can see over here we have YouTube, and then the way MongoDB works is within the database you have different collections. Collections are like tables. So this YouTube DB has 2 tables, Pokemon and Pokemon New. So we're gonna go to the DB and then get the Pokemon collection, because that's where all our data is. So at this point, this should give you all the data that you have whenever you do a query. And then we're also gonna instantiate our AWS Polly client. So this is very simple. It pretty much uses the Boto3 client and creates a session by passing in the access key, the secret key, and then the region where your AWS Polly is located in. And lastly, we would need to do one more instantiation, which is our speech recognizer. So what this does is pretty much, I believe this is a Google package. What it does is it lets you speak to the microphone, and it goes through the Google server and then actually tries to spit out what you just said. So if you say Pikachu, it's going to go to the Google server, try to understand what you say, and spit out the result, which in this case should be Pikachu. So it doesn't only have like actual English vocabulary words, it also has different nouns like names of Pokemon or names of cities. So it does a pretty good job of recognizing what you just said. So now we're gonna go line by line, which is because we're actually gonna get to the logic. So the first thing we're gonna do is create a context to get access to the microphone of your computer through the speech recognizer. We're gonna just put a print statement to see how things are going, just to make sure everything's working as expected. And then we are gonna take in an input. So it's as simple as doing speech recognizer dot listen and then the source, which is gonna be the microphone. And this should give you whatever Google thinks you just said. So we're gonna try it out in a bit. And then let's just have another print statement to make sure we follow it correctly. And then I'm gonna copy paste this try except block. So what this is doing is pretty much what you just said, which is in the set text. It's gonna pass it to .recognize Google method, which actually gives the input to Google so that it can understand what you just said. And if for some reason the server errors out and it does not really understand what you just said, in that case, it's just we're just gonna it's gonna throw an error out, so we're just gonna log the error so that we know something went wrong. And let's just put a print statement outside, which is gonna be the search query that Google thinks you said. So let's run it and try it out a few times to see what happens. So we're gonna run it. And you can take a look at the terminal down here. So I'm gonna run the program and then say, let's say cat, and Google should understand that I'm saying cat. 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 There you go. So it says you asked for cat. So we could try a Pokemon to see what it's doing. Mudkip. There you go. It gets Mudkip. Let's do another. Pikachu. It gets Pikachu. So yeah, you can see we're using the recognize Google method to pretty much understand the word we're saying. So that's step one done. Now we have the ability to say out loud the Pokemon we want to know about, and through the speech recognizer package and with the help of Google, we know that the computer understands what we just said, and we have that in our search query. So if we go to the database, every Pokemon has a name, like a Bulbasaur or a Venusaur. So we could theoretically just query our MongoDB database with the name of the Pokemon and try to get data related to that Pokemon. So coming back here, we know that the search query is the variable that's going to actually have the name of the Pokemon. So I'm gonna go ahead and copy this now. And what this is doing is searching for Pokemon in our MongoDB database, right? So I remember I told you before that MongoDB does a fuzzy search. So I'm gonna come over here. So all our data lives in MongoDB, and then just by setting a few configurations within the MongoDB UI, you can have an index set up, which lets you do different kind of queries on your data. So let's say if you have an index. So we have a bunch of fields here, right? So let's say if we have an index set up on one of the fields like name, then we could call MongoDB with a string and tell it to like return anything, any name in the database that slightly matches our query string. If you go to indexes over here, is that the one over here? Yes, so search indexes. So you can see we have an index here called search by name, which lets you search all your data just through that name field. So going back to the code over here, that is what's happening here. So we're referring to the Pokemon collection, and we're calling the aggregate method. And what the aggregate method does, you can look at the documentation, but what it's essentially doing here is it's telling MongoDB to do a search on your database. You have to give it the index which you're actually searching, which is going to be search by name, which is the same index that we have over here. And it's an autocomplete like search. As I mentioned before, we don't want it to be exactly the same because there can be like slight differences. Like there can be various versions of Pikachu, so we might want more than one. So we don't want to do an exact match. We want to do something called a fuzzy match. So yeah, so we're just giving it the search query and letting MongoDB do its thing. And once that happens, we're just gonna get the result. So MongoDB returns to you something called a cursor. So you can just cast it to a list so that you can visualize things better. And we're just gonna print it. And now let's see what's happening. I'm gonna go back and run it, say a Pokemon's name, and see what we're getting. Mudkip. There you go. You see we get a list with only one object, which is the Mudkip over here. Let's see what would we get if we search for, I'm actually gonna iterate through them so that you can see better. So we could do for result and results. And we could do result and then let's just do the name of the Pokemon, right? Right, there you go. And then Mudkip. Mudkip. There you go. So we're getting Mudkip over here. Now let's say what happens if we say like a Pokemon that might have more versions than their basic version. Charizard. Yep, so this is where it gets interesting. So see when we say Charizard, when we're doing the query, it's returning to us all three versions of Charizard. So this is where our function over here, similar, is going to come in. So we can pass similar what we said, which is Charizard, and all the three returned by our database. And then this should find the one that is the most similar. In our case, it's going to be the basic Charizard. So that's what we're going to do. Let me get rid of this. So what we're going to pretty much do is we're sorting the list that MongoDB is returning. And what we're sorting it by is, so you can pass it a lambda function, which is the function it's going to use on every element to decide where the element should go after sorting. We are passing it our function similar, which is the function over here, which we talked about before. And to similar, we're giving it the name of the item in the database results and the query itself. So let's say in this case, there's three items, right? We have Mega Charizard Y, X, and Charizard. So we're going to call the similar function 3 times. All 3 times, the second argument is going to be Charizard, but the first argument is going to be Charizard, and then Mega Charizard X, and then Mega Charizard Y. So we're going to calculate this ratio 3 times, and we're going to get 3 values, and based on that values, we're going to sort the array in a descending order so that the highest value is at the front, and the highest value would be the Pokemon that is the name whose name is the most similar to our search query. So in this case, Charizard should be the one at the top. So let's see if we do that. So let's just do this, right? So let's do before sort. What was happening is, let's just do print the name. So this is before sort. And then let's just do after, which is going to be, let's just do after sort. And then we're going to just iterate through them again, and then just do this, print it out again, right? There you go. And then let's see what we're getting, right? Charizard. Okay, so the first time we're getting Charizard Y, X, and the basic Charizard, and then we're sorting it, and you can see Charizard going to the top because this is the search query that is the most similar to what we just said, which is Charizard. So this is gonna make sure, like for variations of Pokemons, we get the base Pokemon right at the top. We could try something out. This is just for the sake of trying. Mega Charizard. Okay, there you go. So if you say Mega Charizard, now you're getting a lot of Mega matches because there are a lot of Mega Pokemon. So it gets a bit tricky when you're doing like very specific queries like variations of Pokemon. In this case, we're gonna stick to the basic, which is just a base name of the Pokemon. All right, so we're gonna get rid of the print statements. There you go. So essentially we're getting the results, casting it to a list, and then sorting it by the highest match. And then we're pretty much gonna get the best match. As we saw, the best match after sorting should be the first one in the results array. We don't really need to, okay, we can just skip the print statement there. Okay, so at this point, we should have the ability to say the Pokemon's name out loud, have our program query the MongoDB database using the Lucene index, get the result, get multiple results, find the one that we actually want using the similar function, and sorting the list, and then actually getting the best match, which should be the Pokemon that you asked for. Now that the hard bit is done, what we need is to pretty much form the string that the computer is gonna say out loud, which is what the Pokedex should. So we're gonna just do that. Let's see. So the first thing we're gonna do is make the Pokedex say out the Pokedex entry. So if we saw the last video where we scraped and created the database, you should remember that some of the Pokemons did not have their entry scraped correctly, just because the website had a lot of variations. So we're gonna have a check where it checks if there is if the Pokemon has an entry in the database. By entry, I mean, let's just go to the database. So we could just go to our collections, and then YouTube, and then Pokemon. So if you look at an example, the entry is pretty much this whole text over here. So let me see. Yeah, so checkout Venusaur does not have entry. It just has the wrong entry, which is what we talked about in the last video. So what we're gonna do is check if it has an entry. If it does, then we're just gonna say out the name of the Pokemon, comma, and then the entry. And if it doesn't have an entry, it's just gonna be an empty string. All right, so The next check is going to be where the Pokedex tells you the type of the Pokemon. So what it does is pretty much if it has more than one type, then we're gonna, which is gonna be two, because a Pokemon cannot have more than two types, at least right now. So if it's more than one type, we're just gonna say it's a dash and dash Pokemon, so it's a water and fire Pokemon or whatever. And if it's only one type, we're just gonna say it's an electric Pokemon or it's a water Pokemon. So that takes care of the entry and the type. The next thing is gonna be all the stats. So for all the stats, we're just gonna have it over here, which is gonna be the total, HP, attack, defense, special attack, special defense, and speed. If you look at the database, these are pretty much all the attributes we have over here. And when you're querying MongoDB, every document it returns is pretty much a dictionary. So you can just index through them, like total, attack, or defense. And then we're gonna have a formatted string that gives us everything. So it's just gonna say here are their stats, and then we're gonna just say X total stats, X HP, X attack, X defense, X special attack, all the way to and X in speed. So now we have the entry, the type, and the stats. So we're gonna concatenate all of them together. So we're just gonna have the with entry, and then a new line, the type, and the new line, then the stats. And let's print it out and see what we're getting, right? I'm gonna get rid of the other print statements. Okay, I already got rid of them. All right, let's do this now. Let's do this now. So we're gonna run it and then say the Pokemon's name out loud and see what is our formatted text saying, which is what the Pokedex would say later on. Pikachu. There you go. We're getting the text over here. It says it's an electric Pokemon. Here are their stats, and then blah blah blah, all the stats. Do notice over here we don't have the Pokedex entry. That's because for Pikachu we don't have it in the database. Let's try another Pokemon which would have the entry, most probably. Bulbasaur. There you go. So for Bulbasaur, you can see we're getting the text over here, which is what we want. Alright, so now that we have it, now it's the last part of the Pokedex where we use Amazon Polly to help actually say out loud whatever text we're seeing in the console right now. So it's super simple to do that. We're gonna get rid of the print over here. So remember we instantiated the Polly client over here, which is the AWS service we're using to do our text-to-speech conversion. So we're pretty much referring to that Polly client using a method called synthesize speech. You give it a voice. They have multiple voices. We're just going with the default one. You give it the output that you want. So once Amazon does the conversion, how do you want the data? We want it in an MP3 file. And then you want to pass it the text that you want to convert. In our case, it's the full text that you see over here. Right. So this should give us the, this should let AWS do the conversion and return to us the file in an MP3 format, which we can write locally. So once we do that, we are just gonna open a new file locally. Let's call it entry.mp3. We're gonna actually write to the file. The way we do that is the response comes with the audio stream, which is like a binary data. We are writing the binary data in our entry.mp3 file, which we just created. And then we're gonna just close the file so that it's saved correctly. Once we close it, we're just gonna use our play sound function, which is all the way over here. You remember the package that we imported. We're just gonna use that, give it our file, which is entry.mp3 in the local directory, and it should say out loud the whole entry that we created. So let's try it out with a few, right, and see if it works. I'm gonna increase the volume. There you go. Pikachu.
It's Pokemon. Here are their stats: 320 in total stats, 35 in health, 55 in attack, 40 in defense, 50 in special attack, 40 in special defense, and 90 in speed.
Alright, so there you go. Let's try another one. Totodile.
Totodile. Its well-developed jaws are powerful and capable of crushing anything. Even its trainer must be careful. It's a water Pokemon. Here are their stats: 314 in total stats, 50 in health, 65 in attack, 64 in defense, 44 in special attack, 64 in special defense, and 43 in speed.
And we're gonna try one more over here. Let's do that. Talonflame.
Talonflame. In the fever of an exciting battle, it showers embers from the gaps between its feathers and takes to the air. It's a fire and flying Pokemon. Here are their stats: 499 in total stats, 78 in health, 81 in attack, 71 in defense, 74 in special attack, 71 in special defense, and 126 in speed.
Alright, and we're gonna do one last, a newer Pokemon. Scorbunny.
Scorbunny, a warm-up of running around, gets fire energy coursing through this Pokemon's body. Once that happens, it's ready to fight at full power. It's a fire Pokemon. Here are their stats: 310 in total stats, 50 in health, 71 in attack, 40 in defense, 40 in special attack, 40 in special defense, and 69 in speed.
Alright, so there you go. You can see the working version of the Pokedex here. It's still a pretty basic version because it doesn't do a lot of the details that we could have done, but we can do that in a future video. So hopefully you learned something from the video. I'm gonna link the code and everything down in the description, and feel free to comment if you have any questions or suggestions. That being said, I'll catch y'all in the next one. Bye-bye.